Hello, everyone. Welcome to Backyard Musings, broadcasting live from Apple Valley. I'm Steve.
I'm Scott.
Thank you for joining us today. Our today's segment is about a scientist that did modeling for when she thinks the Arctic ice is going to melt completely. Um, that's the first half of the segment. The second half is our report based on science. So the quote I'm going to read to you for the opening, and I'm going to use emphasis here, and you'll know I'm emphasizing how wacky this sounds. All right, the Arctic
I mean,
could.
kind of like this is like Greta Thunberg territory, right?
I know. How dare you? The Arctic could experience its first summer with nearly all sea ice melted as soon as 2027. For the first time, an international research team, including University of Colorado Boulder climatologist Alexandra Jan and Celine Hughes from the University of Gothenburg in Sweden, used computer models to predict when the first ice-free day could occur in the northernmost ocean. An ice-free Arctic could significantly impact the ecosystem. I think it would. Well, I don't know about significant, but it could impact it and Earth's climate by changing weather patterns. End quote. The first ice-free day in the Arctic won't change things dramatically, she said. Jan said. She's the associate professor of Department of Atmospheric and Oceanic Sciences and fellow at CU Boulder's Institute of Arctic and Alpine Research. But it will show that we've fundamentally altered one of the defining characteristics, how dare she say we, of the natural environment in the Arctic Ocean through greenhouse gas emissions. Would you like to know more?
Yeah, just a little background. I tried to get into that program, that Arctic and Alpine research, but yeah, it was
You
full.
did?
It was full. Yeah, I'm kidding you.
Oh,
But I'll bet it's full. I'll bet you there's plenty of people that are trying to get into that program. So as the climate warms from increasing greenhouse gas emissions, sea ice in the Arctic has disappeared at an unprecedented speed of more than 12% each decade. That's pretty substantial, right?
Yeah, if
Uh,
it's accurate, 12% each decade. Well, every 10 years. Yeah, yeah.
yeah, that might affect some beachfront property. So, um,
Eventually, yeah, definitely.
in September, the National Snow and Ice Data Center, which I didn't know we had one of those, but I guess we do,
Yeah.
reported that this year's Arctic Sea ice minimum, the day with the least amount of frozen seawater in the Arctic, was one of the lowest on record since 1978 at 1.65 million square miles or 4.28 million square kilometers. This year's minimum was above the all-time low observed in September 2012, so about 12 years ago, right?
Yeah.
It still represents a stark decline compared to the average coverage of 6.85 million square kilometers between 1979 and 1982. When the Arctic Ocean has less than 1 million square kilometers of ice, scientists say the Arctic is ice-free. So there
1
you go.
million square kilometers. So we're half a million square kilometers. So we are
Yeah.
3 million square kilometers away from that. Huh. Yeah. Um, Previous projections of Arctic sea ice change have focused on predicting when the ocean will become ice free for a full month. Jan's prior research suggested that the first ice free month would occur almost inevitably and might happen by the 2030s. As the tipping point approaches, Jan wondered when the first summer day that melts virtually all of the Arctic ice sea will occur. Maybe there's a bet going on. Maybe it's on the odds line in Vegas when that will occur.
Can there be
Because
can there be any tampering in this ice melt? Can there be anybody like, I don't know. I mean,
setting up heaters
yeah,
on
going up
top or below,
what do you call those flames?
mirrors.
Heaters or whatever. I don't know. I don't know. This is
Wasn't there a James Bond show where the dude had a satellite and he melted a whole bunch of an Arctic shelf to try and kill James Bond with his satellite laser?
I
All
know,
right.
I know this is going to surprise you, but I'm not much of a Bond guy. But
Oh, okay.
so, but anyway,
All right. Because the first ice-free day is likely to happen earlier than the first ice-free month, we want to be prepared. It's also important to know what events could lead to the melting of all sea ice in the Arctic Ocean, Hughes said.
okay. Jan and Hughes projected or estimated the first ice-free Arctic day using output from over 300 computer simulations.
Oh, that's a lot. That's a
Uh,
lot.
That's a lot. Yep. They found that most models predicted that the first ice-free day could happen within 9 to 20 years. That's quite a window. After
After 20, yeah, that's a big window.
yeah, after 2023, regardless of how humans alter their greenhouse gas emissions. Um, okay, the earliest ice-free day in the Arctic Ocean could occur within 3 years. It's an extreme scenario, but a possibility based on models. In total, 9 simulations suggested that an ice-free day could occur in 3 to 6 years. The researchers found that a series of extreme weather events could melt 2 million square kilometers or more of sea ice in a short period of time. Again, a lot of coulds and woulds in this,
Yeah,
or
yeah.
ifs. An unusually warm fall first weakens the sea ice, followed by a warm Arctic winter and spring that prevents sea ice from forming. When the Arctic experiences such extreme warming for 3 or more years in a row, the first ice-free day could happen in late summer. So,
Uh, three years in a row. That's from now until 2027. That's
yeah,
yeah.
yep,
I don't know. I mean, it sounds like she's saying what people want to hear in order to rake in grant money.
yep.
It's,
This green stuff is got a big price tag on it, and I mean, I know a lot of people have been cashing in on this for decades. This is
yeah,
not something, since AOC came on board. This has been going on for a long time. I remember being probably 20 years ago, maybe longer, still in the plumbing industry, and everything was all about green, 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 and all I was seeing was people making a lot of green, green, green. So, you know,
So those kinds of warm years have already happened. For example, in March 2022, areas of the Arctic were 50 degrees Fahrenheit warmer than average, and areas around the North Pole were nearly melting. With climate change, the frequency and intensity of these weather events will only increase, according to Hughes. Sea ice protects the Arctic from warming by reflecting incoming sunlight back into space. That makes sense. With less reflective ice, darker ocean waters will absorb more heat from the sun. That makes sense, further increasing temperatures in the Arctic and globally. In addition, warming in the Arctic could change wind and ocean current patterns, leading to more extreme weather events. That sounds plausible around the world. But there's also good news: a drastic cut in emissions could delay the timeline for an ice-free Arctic and reduce the time the ocean stays ice free, according to the study. Well, I think that a drastic cut would delay, but
again,
we're just a little sliver in the time span of this Earth, you know.
yeah, whenever I hear cut in emissions, I immediately think of petroleum-based products in manufacturing,
Yeah, yeah.
fuel, just and again, and who's going to take it in the fanny? Um,
The workers
we, the
and
people, workers.
yeah,
Yeah.
trying to
So
put food on the table.
yeah,
So, and quote, any reductions in emissions would help preserve sea ice, Jan said. Well, that's a true statement, too.
I guess I guess so. Um, so let's look at Earth science instead of models. The past million years of the Earth's history has been characterized by a series of ice ages broken up by relatively short periods of warmer temperatures. The Earth's climate has been quite stable over the past 11,000 years. I wouldn't know, playing an important role in the development of human civilization. Prior to that, the Earth experienced an ice age lasting for tens of thousands of years. These ice ages are triggered and ended by slow changes in the Earth's orbit. But changing atmospheric concentrations of CO2 also plays a key role in driving both cooling during the onset of ice ages and warming at their end. The global average temperature was about 4 degrees Celsius cooler during the ice age than it is today, or the last ice age. There's a risk that if emissions continue to rise, the world warms more this century than it did between the middle of the last ice age 20,000 years ago and today. CO2 acts as a control knob for the Earth's climate. It also acts as a cautionary tale of how the climate can experience large changes from relatively small outside forcings. So
Yes. So the CO2 has most effect at the beginning and the end of these ice ages. And these ice ages are tens of thousands of years old. And they know that from doing corings primarily in Antarctica, because that's been covered with snow forever. But doing a coring where you can go down deep, that tells you, what was in the atmosphere and what was happening. So this is science. This isn't a model where you tweak an X and you tweak in a Y and you come out with Z. This is science. All right. The Earth has experienced a number of periods over the past million years in which the large continental ice sheets have covered much of the northern hemisphere. These ice ages are associated with a large drop in global temperatures, 4 degrees Celsius or more below today's levels. 4 degrees Celsius, that's significant for our Earth. With much larger changes over land and in the high altitudes, these ice ages are punctuated by interglacial periods where temperatures rise to around current levels. The most recent ice age occurred between 120,000 and 11,500 years ago. Again, that's a big window, right? But there's not too many areas where you can core 1,000 feet of ice. There's just not that much around the Earth, and it's Antarctica, which is land-based, is about where you can do that. While the current interglacial period, the Holocene, it's called Holocene, is expected to last for an additional tens of thousands of years, and human activity may inadvertently delay the start of the next ice age even further. So let me throw up this slide here. I got a slide for you. All right, Scott, go ahead.
Go ahead.
Yep.
Okay. So on this slide, we got ice age cycles are primarily driven by periodic changes in the Earth's orbit. 3 distinct orbital cycles called the Milankovitch cycles after their discoverer, Serbian scientist Dr. Milutin Milankovitch, interact to change the distribution of incoming solar energy in ways that dramatically affect the Earth's climate. So these include precession, a 26,000 year shift in the orientation of Earth's axis of rotation that affects how much summer sun is received at high altitudes or latitudes, and shifting how much reaches the north versus the south. Obliquity, a 41,000 year change in the tilt of the Earth's axis relative to the sun that changes how much sun is received during a year at the poles versus the equator. And then eccentricity, a 100,000 to 400,000 year change in the shape of the Earth's orbit around the sun that alters the length of the seasons and affects the importance of precession. So
yeah, so these are we did a segment on the Earth tilting, right?
Yeah.
Remember, Scott, because you keep drilling water and selling it to China, that makes the Earth tilt faster than it normally would.
Yeah.
And all these factors, and they have different timelines, so they intersect with each other because of the different timelines. The way we're positioned around the sun, we're just not going around the sun in the same, orbit. Our orbits are slightly changing over time, right? And the Earth is slightly changing its tilt over time, so that is affecting the different ice ages. It's not. That's the major thing. It's not humans creating exhaust and punching a hole in the ozone, which is bad, but that's not going to cause the end of the world.
Yeah.
Okay.
So don't worry about using your right guard aerosol deodorant can, or raising a cow or a sheep or some chickens because of their flatulence and affecting that. That's where I'm at. This
Yeah.
kind of stuff's been going on a long time, and at the very end, I think it comes down to um, a higher power. But anyway,
Yeah. Heavenly Father designed this whole universe, our Earth, the solar system, and the stars, to follow certain laws that affect how this Earth that governs this Earth,
yeah,
and this is
and,
just one
and
of them.
it's a long-term governance, right?
Yeah,
It's eternal.
like eons, like I mean, eternity. We are eternal beings. Right
Yeah,
now, we're just on the Earth for a short duration to be tested and receive our bodies.
yeah.
All right, these three cycles overlap in different ways over time, given their different periods, which means that ice ages do not always have the same duration. None of these cycles substantially changes the total amount of energy reaching the Earth from the sun. Rather, they mostly act to change the distribution of the sun's energy across the surface of the Earth. When these cycles cause the northern latitudes to get less sun in the summer, it allows ice sheets to begin to expand. These ice sheets in turn reflect more incoming sunlight back to space, resulting in a positive feedback that drives additional regional cooling. The northern latitudes matter much more than the southern latitudes, at least over the past few million years, as it contains more land area, which can more easily become ice covered than the oceans, and because the Antarctic has remained covered in ice.
Okay, so this is a quote from Professor Richard Alley, and he's a professor of geosciences at Penn State University. The effect of the orbital features on the total sunlight reaching the Earth is almost zero. The sunshine is just moved between areas and seasons, but the whole world cools into an ice age, and the whole world warms coming out of an ice age, despite half the world getting less sun when the other half gets more. And as for all the explanations of this require the effect of the CO2, which beautifully explain it.
Yeah, exactly. Let me flip to the next slide here. Here we go. So this is like a temperature distribution, and it's really small, and I don't have my glasses on. On the right hand side are the temperature Celsius, and on the left hand side is the metric tons per whatever of CO2. So you can see the relation. The more CO2 you have, the warmer it's going to get. The less CO2 you have, the cooler it's going to get. So let me get back to what I got to read. There's a well-known correlation between temperatures and carbon dioxide concentrations over glacial periods, which correlation is reconstructed from hydrogen isotope analysis and atmospheric CO2 concentration from air bubbles trapped in Antarctic ice over the past 800,000 years. Again, science, not modeling on a computer to fit what you want it to be. Observing what is there and making an interpolation based on what you see. Air bubbles are accessed by drilling ice cores down through the ice sheets and glaciers. Ice cores are just one example of proxy data where climate information from the distant past is gathered from indirect evidence that is locked up in various forms across the Earth.
Changes in orbital cycles do not immediately cause rise or falls in atmospheric CO2. Rather, initial increases in ice cover, high altitude areas trigger feedbacks that cause atmospheric CO2 to fall at the start of ice ages. This happens in a multitude of ways. As ice sheets grow, sea levels change dramatically, falling around 120 meters compared to today's levels, and exposing large areas of land currently underwater and allowing growing vegetation to take up more CO2.
Doesn't that make sense?
It does, yeah.
Yeah.
And that kind of goes along with what we got now, right? I mean,
Yeah.
that's so colder ocean water dissolves more CO2, absorbing more from the atmosphere, though this is somewhat offset by the effect of higher salinity, salinity on ocean CO2 absorption as fresh water from snow freezes into ice sheets.
Yeah.
So,
In addition, ice age glaciers grind up rocks into dust that provide nutrients to ocean life, helping boost the amount of carbon in deep ocean as plants get eaten and into the ocean. Expanded sea ice also covers up regions of the ocean where upwelling helps bring deep ocean CO2 back up to the surface, limiting the amount of CO2 that can be released from the oceans back into the atmosphere. Changes to ocean circulation driven by winds, evaporation, and salinity also play a role in the reduction of CO2 associated with the onset of glaciation. Finally, falling sea levels also impact the growth of coral reefs and other ocean ecosystems, which affect the amount of CO2 stored in the ocean.
Okay. Greenhouse gases created by man are insignificant to those produced by Earth and its orbit around the sun. Climate fear mongering generates money, like we talked about earlier, while science actually explains what is really going on. So I just but going back to basics, I mean, basic science that you learn probably in elementary school or maybe junior high, I don't know. But we go through periods of drought, we go through periods of excessive amount of water. Some people call it flooding, or whatever they call it now, El Nino, La Nina. But basically, most storms come out from the ocean, at least here on the Pacific coast, and they bring storms in. All that water that is gathered from the ocean is got some saline to it, right? Some salt, and it dumps water up in the mountains, which creates snow or rain. If that was so bad, then why is that not killing all the vegetation in the mountains? It's part of God's plan. I mean, He's figured this out, right? I mean,
He's figured it out.
He's figured it out, and I'm not saying that man can't have some kind of influence on that and the way we do things, but I'm a firm believer, and I believe you are too, that if things got too out of whack, there would be a cleansing.
There would be a correction. Yep, a cleansing.
There would be a correction. So
yeah. So like I don't want, like, when you go to China or India and you see like this heavy fog that people are wearing masks, nobody wants that, right?
Yeah,
I mean,
absolutely. It's not helping.
No, that's not helping at all.
Right.
But nobody wants to shove it down our throats, that you must do this and you must do that and control our actions,
Well, that's a good example, because in the United States, we've done, not only because of this greenhouse climate change stuff, but we have done better. I mean, growing up in Southern California, when you go to LA now, you don't see near the type of smog and garbage in the air that you used to 40 years ago, or maybe even longer than that. So there's been some improvements on that, emissions in cars, factories, whatever. But then you go to places like India and parts of the Middle East and China, like you said, Russia, they're not doing any of that stuff.
Yeah.
And we're all on the same world. So somehow it's being affected. We talked about once a while back about some of these petroleum disasters where they've had oil spills, tankers have had issues, or they had that one leak in the Gulf of Mexico. Those things have been rectified either by man's help, but I believe by a higher power's help, because it's just a way of, again, just cleansing it. Take the earth has been around a lot longer than we have, and it's just a way that was set up divinely to correct those kind of issues that Heavenly Father knew was going to happen. So
it isn't by chance, and it isn't by accident.
Absolutely. So anyway.
Okay, folks, we appreciate you joining us this afternoon, and watch for us tomorrow morning. We got another fantabulous episode. Thanks a lot. We'll talk to you later.
Take care, everyone. Have a good day.